Hey everybody, your TA Jungjin here, and this is going to be the first of a 5-part video miniseries that will go over the experimental procedure for your project. Now this was going to be a physical lab session for you guys, but obviously we can't do that in the current situation we are in, so I'll try my best to make these videos as best as I can, so that you guys can still get a good learning experience. But since there will be some limitations, do let me know if you feel like you need some more explanations or photos or videos, or anything really, to compensate for not being able to do these experiments with your own hands. Alright, so in tutorial number 3, I briefly talked about the 3 pillars of modern science and engineering, namely theory, experiments, and computational modeling. And the whole gist of it was that in aerodynamics and fluid dynamics in general, it is especially important to be able to consolidate all 3 aspects, just because of the sheer complexity of fluid physics. And that more often than not, you'll find yourself relying the most on experimental results, guided by theory and numerical simulations. Okay, so how do we conduct aerodynamic experiments? Well, there are a few different ways, but usually what you want to start with are wind tunnel experiments. And I'm sure most of you are at least familiar with the concept. I mean, the name is pretty self-explanatory to some sense. You got a tunnel, you got wind blowing through it, and with whatever you're testing in the middle. But wind tunnels and wind tunnel experiments are actually not so straightforward to design and make, and a lot of time and money goes into getting the setup just right. So let's try and understand a little better about how wind tunnels work with a little bit of history. For centuries, and arguably millennia, mankind aspired to be able to fly. Like in ancient Greek mythology, master craftsman Daedalus, so like the Sifu of Sifus, and his son Icarus escaped from the tower that they were being held imprisoned by flying away using wings that they crafted from a bunch of feathers that they collected and then glued together using candle wax. And before they jumped off the tower, Daedalus warned his son to not fly too low near the ocean since it would dampen the wings and make them too heavy to fly, and also to not fly too high because the sun would just melt the wax. Long story short, Icarus didn't listen and ended up plummeting to his death, but that's not the point I'm trying to make. The moral of the story for us is that even in ancient Greece, people had these hypotheses about aerodynamics and flying. Leonardo da Vinci had some wacky ideas too that didn't rely on wax to hold everything together, like this glider that looks like a bird or this helicopter thing. Among something like 500 sketches and 35,000 words detailing his thoughts and observations about flight. I mean, this guy was practically obsessed about flight, and if he was brought back from the dead today, he'd probably be wetting his pants from excitement. And it wasn't until the 18th century that some whirling arms were used to try and measure drag. But soon after that, in the late 19th century, the first wind tunnel was invented in Great Britain, and after that, wind tunnels got pretty popular, and the Wright brothers made one for themselves too before they built the world's first motor-powered airplane in 1903. But it was still kind of in the early days of history of aerodynamic engineering, so not everyone was succeeding so well. With modern-day understanding of aerodynamics, all these machines look pretty ridiculous. But I mean, you really got to give them credit for trying to pioneer aviation when there really wasn't much knowledge about flying machines. But anyway, the invention of the wind tunnel was a phenomenal breakthrough. And in present times, we have wind tunnels in all sorts of shapes, sizes, and capabilities. We can first classify whether a wind tunnel is open or closed circuit. Open means that the air is drawn externally, while a closed circuit one would keep recycling the air inside. You can also classify them into the range of speeds that they operate in, like low speed, subsonic, supersonic, or even hypersonic, and also by the size of the test section. And honestly, there's so many variants for different specific purposes that each wind tunnel design is really an engineering product of its own. But generally speaking, you can think of the anatomy of a wind tunnel as being 3 or 4 sections. In the case of the open wind tunnel, you have a motor-powered fan sitting towards the end of the diffuser that pushes the air through the tunnel. The diffuser is there to slow down the air and minimize energy losses, and you'll probably understand this better after Larry's lectures on one-dimensional isentropic flows. Okay, so that was the diffuser, but at the front of the intake, you have a converging section here. That there is to speed up the huge amount of air that is being sucked in by channeling it through a decreasing cross-section area. That's just conservation of mass, right? And then of course you have the test section sandwiched between the converging section and the diffuser. Now a closed circuit wind tunnel would just have guiding vanes at each corner to make sure that the flow can make the turns. All right, so in lecture 11, Larry talked about the wind tunnel facilities on our campus, but you guys probably have never seen it, so let me show you where it is. Right now I'm outside the CYT building. Let's go. Okay, so this small wind tunnel, the 0.4 meter one, is actually in the CYT building on the first floor. And that would be you, Sal. And over here, we have the Aerodynamics, Acoustic, and Noise Control Technology Center, or AANTC. Okay, and then right here in room 1001C of the CYT building, we have the small wind tunnel. Hi, Matthew. Thank you. All right, so this little room here has the small wind tunnel. The cross section is 400 by 400 millimeters, right?
Yes.
Okay. And is it okay if I step in with my shoes?
No problem.
Okay. All right, so you probably saw it in the CAD file a couple lectures ago. This is what it looks like in real life, and that would be the anechoic chamber, right?
Yes.
Okay. So if you want to do any tests here, you would actually have to go inside the anechoic chamber and put your test piece there, and then you have this pretty big closed circuit wind tunnel that goes up to 70 meters per second. Is that correct?
Yes.
Yeah. Yeah, but this wind tunnel obviously is pretty expensive to run, so, and it is usually booked by postgraduate students or other research projects. So as undergraduates, you probably won't be able to use this tunnel very easily, but if you are working on a project that requires wind tunnel experiments, you could try and do that here. All right, thank you, Matthew.
Son?
Okay, so that was the small anechoic wind tunnel. I did want to show inside the quiet room as well, but there are some experiments set up there, and so I won't be able to show you how it looks like inside. Okay, but that's okay. Now we're going to move on to the other wind tunnel facility, and that is actually right outside next to the south gate. So let's head over there. And we're outside. Hey! I'm making a video for Larry's class.
Oh.
Yeah. See you.
Bye-bye.
Okay, so over on that side, way down there, that is the Southgate bus stop. And this building right here is where the big wind tunnel is. It is the... And let's just head over there. And here we are. Okay, so this building has actually two facilities. The Aerodynamics and Acoustics facility, the AAF, and the Geotechnical Centrifuge facility. We're not gonna look at the centrifuge facility, but yeah. And on the left-hand side, if we go through this door and make our way upstairs, that will lead us to the big wind tunnel. We're not gonna look at that today because Dr. Ryu Fata will give us a proper tour of that facility on October 30th, okay? And if we wanna go to the wind tunnel where we're gonna do our experiments, we're gonna go inside here, all right?
I just get my student ID card. All right, and open. Okay. And here is the workshop area where our wind tunnel is located. Let's just open that. Okay.
So we will be working with a open wind tunnel, and what you see in front of you right now is the converging section part. And as you can see, it contracts quite a lot, and you can tell that it's oriented so that the air right now is coming from the right. And just downstream, we have the test section. And if we make our way down all the way to the end, we have the motor which drives the fan. So basically, you have the air being sucked in from up there, from this fan here, and out this diffuser that is being newly installed. So before adding the diffuser, it was actually just this metal grid thing that just kind of sat on top of the outlet hole there. And because the flow wasn't being adequately slowed down at the exit, there was a lot of energy losses. And so just by adding this little diffuser, the maximum speed that can be reached by the tunnel increased by almost 40%. And here we are at the inlet side with 1 TA for scale. And you may have noticed this honeycomb mesh here. This is to keep the flow straight when it's being sucked in. Alright, so to cap off this first video, here are some basic specs of the wind tunnel that we will be working with in our project. That's all for today's video, and hope you guys are excited for the next one on flow quality.